Water. Water is the most important inorganic molecule in biology. It is a polar molecule that makes up between 70% and 90% of the cell mass. Being a polar molecule means that there is a presence of a delta charge. There's a concentration of electron density around our oxygen, and that results in a delta negative charge. The concentration of electron mass in around the oxygen means that there's a reduction or relative reduction in electron presence in our hydrogen atoms. As a result, the hydrogen atom are left with a slightly positive charge. So we can say that the net dipole bisects the HOH bond angle with the negative end towards the oxygen. Notice the angle between hydrogen is 104.5. This is smaller than what we would otherwise expect in a tetrahedral molecule. So we say that the structure has a bent molecular geometry for the two hydrogen from the oxygen vertex. It is important that you note the electrostatic or the delta charges in each aspect dipole moment of our water molecule. One oxygen atom combines with two hydrogen atoms to form covalent bonds, making 1 mole of water. Notice in our dot and cross diagram that we have two lone pairs and we have two left electrons that form covalent bonds with our hydrogen atoms. Now let us consider the hybridization of orbitals for oxygen. The 6 electrons in your oxygen needs to combine covalently with 2 more electrons to achieve its 8 electron shell stability that it requires. To do so, during the hybridization process, we form a sp3 orbitals. Notice that the first 2 regions are complete with 2 electrons spinning in opposite directions. These 2 first completed regions form the bases of your 2 lone pairs. The last 2 occupied spaces only have 1 electrons each in both of them, thus allowing space for the forming of covalent bonds with 1 hydrogen atom each. The oxygen atom, with its lone pairs of electrons, causes a phase bend or gas phase bend in the angle between your hydrogen atom, which then reduces to 104.48, a much smaller angle than the typical tetrahedral shape of 109.47. The lone pairs are closer to the oxygen atom than the electron sigma bonded to the hydrogen, so they require more space. This increased repulsion of the lone pairs forces the OH bonds closer to each other. The charge differences caused water molecules to be attracted to each other and to other polar molecules. This attraction contributes to the hydrogen bonding and explains many of the properties of water, such as its solvent action.